When you begin using infrastructure as code with Terraform, one of the first best practices you'll likely adopt is using a remote backend to store your state files. However, as many discover, setting up a remote backend introduces a classic conundrum, the chicken and egg problem. Terraform's remote backend is designed to store the state of your infrastructure in a remote data store such as Amazon S3, with optional state locking through services like AWS DynamoDB. This setup ensures that your state is backed up, versioned, and protected against concurrent modifications. The dilemma arises when you consider the following. To initialize a remote backend like S3, you might ideally use Terraform to create the necessary resources, like an S3 bucket. However, to run Terraform and create any resources, you require a backend to store its state. Thus, you need a backend to create the backend. This circular dependency is the essence of the chicken and egg problem in this context. There are many methods available to address this challenge. For example, you can manually create the necessary resources using the management console. You can use the AWS command line interface to set up the required resources. Or you can deploy a bash script that automates the creation of the necessary backend resources. In this demo, you will use Terraform itself and create a remote backend module. A module dedicated to the backend setup keeps the related logic separate from your primary infrastructure code. This separation ensures cleaner, more maintainable, and reusable code. In the first task, you will begin by creating a remote backend module. You will create necessary resources like the S3 bucket for storing state, and a DynamoDB table for state locking. After setting up the backend resources, you will initialize your primary Terraform project, and configure it to use the remote backend, pointing to the resources spawned by the module. With the backend in place, you can continue with your regular Terraform workflows, safe in the knowledge that your state is securely managed remotely. Now, let's get started. Task 1. Creating a remote backend module. In this task, you will focus on setting up the necessary AWS resources required for a Terraform remote backend. You will create a reusable remote backend module that comprises of the following resources. An IAM user for Terraform. This IAM user will have the necessary permissions to manage your infrastructure. It's a good practice to have a specific IAM user for Terraform to limit the permissions and scope of actions that Terraform can perform, ensuring that Terraform has only the permissions it needs and no more. An S3 bucket for Terraform state. This S3 bucket will be used to store your Terraform state file, allowing for easy access and versioning of your infrastructure state. An S3 bucket policy. This policy will specify the permissions for the S3 bucket, allowing the Terraform user to list the bucket and to retrieve, as well as deposit objects within it. A DynamoDB table for state locking. This DynamoDB table will be used to lock the state file when a team member is applying changes to the infrastructure, preventing conflicts. Start by confirming that you are currently in the root directory of your project. You can do this by running the pwd command in your terminal. Use the cd command to move into the Terraform folder within your project. Within the Terraform folder, navigate to the modules directory. Now create your first module folder. In the terminal, enter mkdir, remote backend. Move into the newly created directory using the cd command. Next, create the essential module files using the touch command. In the terminal, enter touch-main.tf. touch-variables.tf. touch-outputs.tf. Next, you will proceed with defining the necessary resources for your AWS remote backend. In the remote backend directory, open the empty main.tf file you just created. Now, refer to the video description below, and open the link to the remote backend reference file. You will find that the Terraform resource blocks required for setting up the backend resources have already been compiled for your ease. These resource blocks are sourced from the Terraform registry. However, the task at hand requires you to manually fill in the attributes for these resources. Copy the code to your clipboard, and proceed to paste it into your main.tf file. Once done, scroll to the top of the file to review your changes. Next, open the remote backend variables file. In the Explorer panel, in the remote backend folder, right-click variables.tf, and choose Open to the side. Defining variables in the variables.tf file is essential, because it allows you to customize settings related to your AWS remote backend configuration. For example, you can easily change the settings for the IAM user, S3 bucket names and DynamoDB table names required for your remote backend setup, without having to modify the actual resource blocks directly in the main.tf file. This separation makes your Terraform code more maintainable and robust. To begin, close the Explorer panel, and maximize the main.tf window to optimize your workspace area. In Terraform, we utilize resource blocks as foundational constructs to define and manage infrastructure resources. These blocks allow us to declare the desired state of specific resources within our infrastructure, such as an IAM user, S3 bucket, and so on. Each resource block corresponds to a particular resource type. The resource type describes the kind of infrastructure resource you wish to create or manage. As an example, on line 2, you have defined a resource type as AWS IAM user. This signifies your intention to define an AWS IAM user resource, thereby instructing Terraform to create or manage an IAM user accordingly. You can find the AWS IAM user resource type in the Terraform registry. Typically, a resource block includes a block label, which is a user-defined name enclosed in double quotes. This label serves as a reference point, allowing you to interact with that specific resource elsewhere in your Terraform configuration. Think of it as an alias for the resource block. On line 2, you will notice an empty string enclosed in double quotes, where the block label should be. Enter Terraform _user as the block label within those double quotes. This will serve as the name for this specific IAM user resource. Within the resource block, you should then define the configuration settings and attributes specific to the IAM user you wish to create. For example, in the name attribute, assign a value to specify the IAM user's name. You have the option to hardcode the IAM username by entering a value like this. Alternatively, it is considered good practice to create a variable instead. Let's proceed to define your first variable. In the variables.tf file, enter variable IAM_user_name. Ensure the variable is enclosed in double quotes, and then add curly braces to the end. With this variable defined, you can customize the IAM user's name by setting a value for it in a terraform.tf vars file. Now, let's reference this variable in the main.tf file. On line 2, simply enter var.iam_user_name. Moving on to the next resource block, you will define the AWS IAM user policy attachment resource type. This resource type is used to attach an IAM policy to a specific IAM user, thereby granting the necessary permissions to that user. Following the resource type, enter a block label in the double quotes. Type, admin_policy_attachment. This label serves as an alias for this resource block. Within the resource block, the first attribute defined is the policy ARN. This attribute is assigned the ARN of the policy that you want to attach to the user. In this case, you will attach the administrator access policy, which provides full access to AWS services and resources. Please remember that this policy doesn't follow the principle of least privilege. You're using it in this demo for simplicity. The next attribute to define is user. This attribute should be assigned the name of the IAM user to whom you want to attach the policy. Here, you should reference the IAM user by its resource name. You can do this by typing the resource block type and local value you gave it. Move down to line 9, and then enter AWS_IAM_user. Terraform_user. Next, you need to reference the unique identifier of the IAM user that was created. In Terraform, each AWS IAM user resource has an attribute named ID that stores the unique ID assigned to the user by AWS. To access this ID, you will need to append a period, followed by ID to the resource reference. Now, let's proceed to the next resource block, which is for AWS S3 bucket. This block will define the S3 bucket that will hold the Terraform state file. Firstly, provide a label for this block. Within the double quotes, type Terraform_state_bucket. The primary attribute within this block is bucket. Instead of hard-coding a bucket name, you will utilize a variable. This promotes flexibility and reusability. Let's define the variable for this. In the variables.tf file, on line 2, enter variable, bucket_name. ensure the variable is enclosed in double quotes, and then add curly braces to the end. Now, reference this variable in the AWS S3 bucket resource block. On line 14, enter var.bucket_name. Next, focus on the lifecycle block. This block configures certain rules for the bucket's lifecycle. You want to ensure that your S3 bucket isn't accidentally deleted. To implement this safeguard, assign the value true to the prevent destroy attribute. Lastly, you will deal with the tags block. Tags help categorize and identify AWS resources. For the name key, you can either hardcode the S3 bucket name, or reference the same variable used for the bucket name. This is because the bucket is specifically and solely used to store Terraform state, and it is unlikely you will change the tag in the future. You can hardcode the tag value like this. However, for consistency, assign the variable bucket name to the name tag instead. Remove the double quotes, and enter var.bucket_name. Now, you are going to enable versioning for the S3 bucket, which is an important step for tracking changes, and ensuring that you can recover previous versions of your data if necessary. You can enable versioning on a bucket by using the AWS S3 bucket versioning resource block. Start by adding a block label within the double quotes. This label serves as an alias for the resource block. In the double quotes type, versioning_enabled. Next, focus on the bucket attribute within the block. This attribute should reference the S3 bucket that you want to enable versioning for. You can reference your S3 bucket by its resource type and block label. By typing AWS_S3_bucket. Period. Terraform_state_bucket period. ID. Now, move on to the versioning configuration block. Within this block, you need to set the status attribute to enable to activate versioning for the bucket. On the status line, type enabled within the double quotes. Now, let's set up the S3 bucket policy. This will manage who has access to your S3 bucket, and what actions they can perform. You can set up a S3 bucket policy with the AWS S3 bucket policy resource block. Start by adding a block label within the double quotes. Let's name it S3_bucket_policy. This label will act as a reference point for this specific resource block. Next, it's time to fill in the details to create a policy that defines the permissions for your S3 bucket. The bucket attribute should reference the S3 bucket to which this policy will be applied. In this case, you are working with the AWS S3 bucket resource that you have named Terraform State Bucket. To reference this bucket, use its resource type, AWS S3 bucket, and the local name you gave it, Terraform state bucket. And then retrieve the bucket's unique identifier by adding period ID. On line 36, enter AWS _S3 bucket period Terraform state bucket period ID. Next, you need to define the policy itself. The JSON encode function creates a JSON encoded policy document. You then start by setting the policy version, which defines the syntax you are using. Here, you are using the 17th of October 2012 version, which is the latest. In the statement attribute, you define an array of individual policy statements. Each statement is a set of permissions that you are granting or denying. In your case, you have two statements. In the first statement, you are granting the S3 list bucket permission, which allows the user to see a list of all the objects in the bucket. Now, you need to define the resource and principal attributes. The resource attribute specifies the object or objects to which the statement applies. In your case, you want it to apply to your S3 bucket. As you are working with the AWS S3 bucket resource that you have named Terraform state bucket, you can simply copy the resource type and the local name from the S3 bucket policy attribute, and then paste it into line 44. You will then retrieve the bucket's ARN, therefore, enter, period. ARN, and then a comma. The principal attribute specifies the user or users to whom the statement applies. In your case, you want it to apply to your IAM user, Terraform user. So, you need to reference the Terraform user's ARN. To reference the Terraform user's ARN, use its resource type, AWS IAM user, and the local name you gave it, Terraform user. And then add the ARN attribute, which holds the ARN of the IAM user. On line 46, enter AWS _IAM user. Period. Terraform user. Period. ARN. For the second statement, you're granting the permissions S3 get object and S3 put object to the Terraform user. This allows the user to both read and write objects in the bucket, which is necessary for managing the Terraform state. In the resource attribute, simply copy the code from line 44 and paste it into line 52, ensuring it's placed within the curly braces. Since you want these permissions to apply to all objects within the bucket, you append / to the bucket's ARN. For the principal attribute, it remains the same as in the first statement. Go ahead and copy the code from line 46, then paste it into line 54. In summary, this policy provides the Terraform user with the ability to list the contents of the bucket and to read and write objects within it. This ensures the user has all the necessary permissions for handling the Terraform state. Moving on to the final resource block, you will utilize the AWS DynamoDB table resource. This resource block is used to create a DynamoDB table that serves as a locking mechanism to prevent conflicts when multiple users interact with the same Terraform state file in S3. Following the resource type, enter a block label in the double quotes. Type, state, _, lock, _ table. This label serves as an alias for this resource block. The name attribute specifies the name of the DynamoDB table. Here, you will assign it to a variable. Let's define the variable for this. In the variables.tf file, on line 3, enter variable table _name. Ensure the variable is enclosed in double quotes, and then add curly braces to the end. Reference this variable in the AWS DynamoDB table resource block. In the name attribute, enter var.table _name. The billing mode attribute defines how you will be charged for read and write throughput. Attributes such as the billing mode can be hard-coded because it tends to remain constant across deployments. In the double quotes, in capitals enter pay _per _request. This billing mode is typically chosen for DynamoDB tables in Terraform state locking, given its automatic scaling with the request volume, allowing you to pay per applications read and write operations. The hash key attribute specifies the primary key attribute for the table. The hash key can also be hard-coded because lock ID is a standard hash key for state locking in Terraform. Here, enter lock ID as the primary key. This means that lock ID will be used to uniquely identify each item in the table. The following attribute block defines the attributes of the table. Here, in the name attribute, inside the double quotes, enter lock ID. And for type, enter S for string, in the double quotes. This defines the structure of the data that will be stored in the table. The lifecycle block is used to prevent the accidental deletion of the table. By setting prevent destroy to true, you ensure that the table cannot be deleted without first altering the Terraform configuration. The tags attribute allows you to add key value pairs that help you organize and categorize your resources. In the name attribute, delete the double quotes and enter var.table _name. After completing your code, make sure to save all the changes you made. In the top menu, choose File. Save all. Now, select the variables.tf window. Open the Explorer panel. And then open the outputs file in the remote backend module. And close the Explorer panel. Defining outputs for your Terraform configuration is beneficial, because it allows you to easily access and view important information about the resources you've created. In this demo, useful outputs might include the ARN of the IAM user, the name and ARN of the S3 bucket, and the name of the DynamoDB table. These values could be useful for reference in other parts of your Terraform configuration, or if you want to easily access them without having to navigate through the AWS console. Let's now write your first output. In the outputs.tf file, begin by typing output IAM_user_ARN. Ensure the output is enclosed in double quotes, and add curly braces to the end. This basically starts the declaration of a new output variable named IAM_user_ARN. Next, specify the value of the output. In the curly braces, press enter, and type value equals. You can locate the value in your main.tf file. In your main.tf file, you have a resource block that defines an AWS IAM user. Scroll to the top, and locate the IAM user resource block. The AWS IAM user part is the resource type, and Terraform user is the name you've given to this particular resource instance. Every AWS IAM user resource has an ARN attribute that contains the ARN of the IAM user. This is provided by AWS when the user is created. In the outputs.tf file, in the value attribute, reference the resource block and name. Type AWS_IAM_user. Add a period, followed by Terraform_user. Then add another period, followed by ARN. You are basically telling Terraform to fetch the ARN attribute from the AWS IAM user resource instance named Terraform user. Once you've added your output block, go ahead and save your outputs.tf file. With your main.tf file written, variables defined, and outputs in place, your backend module is now completed. Now, let's look at the Terraform format command. Using this command for your Terraform files is an essential practice to maintain consistent formatting and improve readability of your Terraform configurations. The command automatically formats your code according to Terraform's style conventions. To begin, open a terminal. In the top menu, choose Terminal, and then New Terminal. Once the terminal is open, move to the remote backend directory, containing the Terraform files you've just created. Start by executing the pwd command to ensure you are in the root directory. Next, input the following commands to navigate to the remote backend directory. cd Terraform, cd modules, and finally, cd remote backend. With the correct directory in focus, type Terraform fmt to initiate the formatting of your Terraform files. Once the command is executed, inspect the terminal's output to verify the changes. If any modifications are made, the command will list the names of the files that were formatted. Conversely, if all your Terraform files are already in line with the formatting conventions, Terraform fmt will not perform any changes, and will return you to the command prompt without any additional output. Task 2. Creating the main configuration file, and referencing the remote backend module. With your backend module set up and ready to go, you are now going to bring all the pieces together in the root module, the core of your Terraform project. The root module is the Terraform configuration located in the root directory of your project. It is a collection of all the Terraform files in your project's root directory. In this task, you will define the AWS provider. Specify the required Terraform version. Reference your remote backend module. And incorporate any necessary variables and outputs. To begin, open the main.tf file located in the Terraform directory. Then, with a right-click, open the variables file in the Terraform directory, and select Open to the side. Proceed to close the Explorer panel, and adjust the dividing line between main.tf and variables.tf, thus optimizing the workspace for your needs. Your next step is to go to the video description below, and open the link to the main.tf reference file. Go ahead and copy the content to your clipboard, then paste it directly into your empty main.tf file. This code, sourced from the Terraform registry, is the AWS required provider block. The required providers block is used to specify which providers are required for your Terraform configuration. This ensures that the correct provider version is used, which is crucial for maintaining compatibility and avoiding potential issues arising from changes in provider syntax or behavior. In this case, you are specifying that you are using the AWS provider, with the source being HashiCorp/AWS, and the version being 5.0 or any compatible updates that follow. Next, the AWS provider block informs Terraform that you will be working with AWS resources and need to interact with the AWS API. The region attribute specifies the location where your AWS resources will be created. In this case, you will use a variable to specify the region where AWS resources will be created. In the variables.tf file, enter variable region. Ensure the variable is enclosed in double quotes, and then add curly braces to the end. You can reference this variable in the region attribute by typing var.region. Next, you need to reference the remote backend module. You are referencing the backend module because you want to use the Terraform configurations defined in that module to create the resources. These resources will then be used for storing Terraform state file. Move down to line 15. Then start by typing module and then backend in double quotes, followed by a space and curly braces. Then press enter. This defines a new module block named backend. The name you choose is simply an identifier that you can use to reference the module within your Terraform configuration. Now enter the source attribute and specify the location of your remote backend module. Type source space equals space double quotes period /modules /remote _ backend. This tells Terraform where to find the module's configuration files. Open the variables.tf file in the remote backend module. Copy all the variable definitions from the variables.tf file to your clipboard. Then close that variables.tf file. Close the Explorer panel and paste the variables from your clipboard into the root module variables file. This step is important because the variables used in the main.tf file must be declared in the root module to avoid errors and ensure that Terraform knows what values to expect. Now you need to specify the variables in the module backend block to pass specific values to the remote backend module, which then uses these values to configure and create the necessary AWS resources for state management. Add a new line within the module backend block. And begin by referencing the IAM username variable. Type IAM_user_name. Followed by equals var.iam_user_name. Next, reference the bucket name variable. On the next line type bucket_name. Followed by equals var.bucket_name. Then reference the final variable. On the next line type table_name. Followed by equals var.table_name. In the final step, you will add an output block. The purpose of adding an output block is to display specific information from your Terraform configuration. When you run Terraform apply or Terraform output, Terraform will show the values of any defined output variables. Move down to line 22, and add an output block. This tells Terraform that you are defining an output variable. Type output. Then enter the name of the output variable. Enter double quotes IAM_user_name. Then to start the definition block for this output variable, enter curly braces and press enter. Then type value equals module period backend period IAM_user_ARN. This output block makes the IAM user ARN easily accessible and visible when you run Terraform apply or Terraform output. Before you finalize your changes, let's enhance the readability and tidiness of our code. To do this, add additional spaces following the equal operators to ensure all the variables align vertically. You have the option to utilize the space bar or the tab key, adding the necessary spaces until all the equal operators are perfectly aligned. Now you need to assign values to each variable. Open the Explorer panel. And in the Terraform directory, select the terraform.tf vars file. Close the Explorer panel. This file allows you to specify values for your variables separately from your main configuration files, making your infrastructure as code more modular and easier to maintain. This separation is useful for managing sensitive or environment-specific information. And it facilitates collaboration and version control by allowing you to share your configurations without exposing your specific infrastructure details. Start by typing the region, equals. And in double quotes, enter your desired AWS region. In this case, enter US-East-1. On the next line, type the second variable. Enter IAM_user_name. Equals. And in double quotes, enter your desired IAM username. In this case, enter Terraform_user. On the next line, type the third variable. Enter bucket_name. Equals. And in double quotes, enter your desired S3 bucket name. In this case, enter Terraform-state-bucket. Followed by your initials. Remember, your S3 bucket name must be globally unique. On the next line, type the final variable. Enter table_name. Equals, and in double quotes, enter your desired DynamoDB table name. In this case, enter Terraform_state_logs. Now save all the files. In the top bar, choose File. And then Save All. Terraform will now automatically use these values from Terraform.tf vars when you run Terraform apply. Having created the remote backend module, and configured the main configuration file, it's time to save and track these changes using Git. This will be your second commit in the project's Git repository. Open a new terminal, and ensure you are in the project's root directory. To stage all the changes for the commit, enter git add period. Next, commit the changes with a clear and descriptive commit message. Enter git commit -m. Double quotes. Added remote backend module. And configured main configuration file. Finally, push the commit to your GitHub repository to ensure that your remote repository is in sync with your local changes. Enter git push. By committing and pushing these changes to GitHub, you ensure that your project's progress is accurately tracked, and could be accessed and collaborated upon by others. Task 3. Initializing the Terraform configuration and deploying remote backend resources. Now that your main configuration file is set up and you've committed the changes to Git, the next step is to initialize your Terraform project and apply the changes. Open a new terminal and maximize the panel size. Now navigate to the directory where your Terraform configuration files reside. Enter cd Terraform. Once you are in the root directory of your Terraform configuration, run the Terraform init command to initialize your working directory. Enter Terraform init. The first step initializes the backend for the Terraform project. The backend is where Terraform stores state information. In this case, it sets up a local backend since it doesn't specify a remote backend being initialized. The second step initializes the modules. Here, the backend module is being initialized. The third step initializes the necessary provider plugins based on your configuration. In your case, it's initializing the AWS provider plugin, and Terraform will use the latest minor version, that is greater than or equal to 5 but less than 6. You must rerun Terraform init if you ever change the configuration of your modules or backend. This is to ensure that the working directory is reinitialized and updated based on the new configuration. After running Terraform init, the next step is typically to validate your configuration with Terraform validate. This command checks whether your configuration is syntactically valid and internally consistent, without accessing any remote services. Now in the terminal, enter Terraform validate. If there are any issues or errors in your configuration, Terraform validate will display an error message explaining what needs to be fixed. If the validation is successful, Terraform will display an output: the configuration is valid. You can then proceed to the next step, which is running Terraform plan. Terraform plan allows you to see the changes that Terraform will make to your infrastructure. This is useful, as it helps you review and confirm the changes before they are actually applied. In the terminal, enter Terraform plan. You can see the Terraform plan will create all the resources you defined in the remote backend module. It will also output the IAM user's name. Once you are satisfied with the plan, proceed to apply the changes with the Terraform apply command. You can also append the auto-approve flag to tell Terraform to automatically approve and apply the changes without interactive confirmation. In the terminal, enter Terraform apply. -auto-approve. Terraform will begin applying the changes and display outputs detailing the progress. The outputs will show each resource being created. Once Terraform has completed applying the changes, review the output to confirm that the resources were created. Terraform will also output the IAM user's name. You can always view the outputs again after running Terraform apply, by running the Terraform output command. Congratulations on successfully deploying your remote backend module. By deploying the backend resources, you've laid the groundwork for configuring your remote backend. These resources are crucial as they will store the state of your infrastructure and enable collaboration with your team by locking the state to prevent conflicts. Task 4. Configuring a remote backend for Terraform state. When you initialize and apply Terraform configurations without specifying a remote backend, Terraform stores the state of your infrastructure in a file named terraform.tf state in your project directory. This is called the local backend. Now let's view this file. In the Explorer panel, open the terraform.tf state file in the Terraform directory. The Terraform.tf state file contains the following: a representation of the resources in your infrastructure, the metadata necessary for Terraform to manage the resources, attributes of the resources as returned by the provider. There are a few benefits of using a local state. A local state is easy to set up, and doesn't require any additional configuration for remote storage. The state file is stored locally, so it's quickly accessible. You can easily open the state file and see the current state of your infrastructure. However, there are limitations to a local backend. A local state doesn't work well for teams because the state file is only available locally. There's no built-in versioning or history for the local state file. Storing state files locally can expose sensitive data, especially if not handled securely. There's no locking mechanism with local state to prevent conflicts when multiple users try to apply changes at the same time. As you have deployed the resources required for the remote backend, in this task you will now migrate the local backend to a remote backend. You will configure Terraform to use an S3 bucket as a backend for storing your Terraform state file, and use DynamoDB for state locking. Now close the state file, and in the Explorer panel, open the backend.tf file in the Terraform directory. Now, you will define your backend configuration. Begin with the Terraform block. Type Terraform, followed by curly braces, and press Enter. This starts a new Terraform configuration block. It's time to define the backend type. On the next line, type backend, double quotes, S3, followed by curly braces, and press Enter. This tells Terraform that you are configuring an S3 backend. Proceed to specify the S3 bucket name. This tells Terraform where to store and retrieve the state file. On the next line, type bucket equals, double quotes, the name of your S3 bucket. Now indicate the path for the state file. By specifying a path, you're defining where in the S3 bucket the state file will be saved. This is important for organizing your state files in a way that makes sense for your project or organization. On the next line, type key equals, followed by double quotes, website, /terraform.tf state. Advance to specifying the AWS region. Specifying the region helps Terraform know where to find and interact with the specified S3 bucket that will hold your state file. On the next line, type region equals, double quotes, US-East-1. Lastly, specify the DynamoDB table for state locking. On the next line, type DynamoDB _table equals, double quotes, followed by the name of your DynamoDB table. It is a good practice to keep your code tidy and organized. You can align the equals signs to make the configuration more readable and easier to understand. Adjust the spacing before each equals sign, so that they align vertically with each other. Conclude by saving the changes to your file. Having configured your remote backend, It's time to transition from the local backend to the remote one. Start by opening a new terminal. Navigate to the Terraform directory. Enter Terraform init. Upon executing Terraform init, Terraform will identify the backend configuration alteration and prompt you to migrate the existing state to the new backend. A confirmation will be requested to transfer the existing state to the new backend. Type yes to approve the migration. To verify the migration, inspect the local copy of your state file. It should now be empty. Additionally, check your S3 bucket to ensure the state file has been accurately copied over. Now that your backend is migrated, you can continue to develop your infrastructure using the remote backend for state management. However, before you proceed, let's commit your updated configuration to version control. In the terminal, stage the changes you've made using the git add command. Enter git add followed by a period. This command stages all the changes in the current directory and its subdirectories. Now that your changes are staged, you can commit them to your local repository with the git commit command. In the terminal, enter git commit -m double quotes. Enter a descriptive message of the changes you've made. Enter migrated Terraform state to remote S3 backend. Finally, you can push your changes to the remote repository with the git push command. In the terminal, enter git push. These commands will stage, commit, and push your changes to the remote repository, making the migration to a remote backend part of your project's version-controlled history.